That's actually one thing that's quite special, so that we can really simulate how it feels on Mars. Yes. It's one of the most important things we do here, because what we learned in a lot of field tests is that there are lots of things you just don't think of if you don't try them.
I mean, that's maybe the most important thing of all these tests here. As Stefan says, you don't think of a lot. It's amazing of how many things you do not think when you plan such a project. And you only discover them by doing such experiments, field tests. And every time we do it, there is then a little thing which can be done better or in a different way.
Sure, yeah. The blue blinking light actually is a sign that we receive a...
That he is still alive.
Has a heartbeat.
That tells us he is alive.
It's also the rhythm, the correct rhythm?
Yes.
That would be...
It reminds me of the old film with Louis de Funès when they just bang on the tube. It's the extraterrestrial.
This device was made by one of our guys. It's really impressive work. It's called Ego device. And it's working with Bluetooth.
Looks like this.
Yeah, look like this.
And it's mounted like, the sensors from the jogging belts. It's the same, but it has...
The GoPro harness.
Yeah, and it has a really good ECG, so everybody of our medical team who saw the ECG the first time said, oh wow, that's good. Yeah, so yeah. And it really works very stable and very good, so that's one thing that we appreciate.
I'm not sure.
I give you the outer layer.
Yeah, that would be really...
That's cool.
Yeah, but how do we fit all the electronics in
We
there?
were talking about space hockey. We could make a UDA space or a space hockey with the outer layer.
Really would like that, yes.
Yes.
Either for him or for another one. Can we even get another
So
one?
we just need somebody who knows to sew. This is a special material. This is a Panox Kevlar. This is very
Strong.
heat resistant. It's also used for firefighters. And we chose this material because we are also doing a lot of contamination experiments, because when we go to Mars, we don't want to bring anything with us. At the same time, we also don't want to pick up something. And if you mix up everything and go back in your lab and look through the microscope, we don't want to detect that it was our DNA. Yeah? And that's what's very important, to work very clean. And this one is chosen because not many things stick on it. Yeah. It's still a very hard issue to work clean. And there are 2 experiments, I think. One with the JPL, the Jet Propulsion Lab. They will do with the terbium beads. We will have a call to them later in the afternoon at 4 o'clock. So the PI will explain what they're exactly doing. And there's another one from the Netherlands. I think they also live in space something. She also have different techniques to test what's working best to not contaminate anything.
Remember, please, no pictures of the open one.
Question, is it also radiation resistant, or is it not?
No.
So it can't actually be used on Mars yet?
No, that was, by the way, also important what Olivia just said. On Mars, we don't want to bring anything from Earth, and we don't want to take anything dangerous away. The same goes, maybe we make that now, rather than in the afternoon when it's hectic. The same goes for a normal mountain here in Austria. So please, that's just a normal safety behavior code of conduct thing. So please don't take anything from the cave, and especially don't break stalactites or something, because there are people, how nice, and then they have it in the hand, and also don't leave anything. That's very important, because then we get in trouble. So the general mountain rule for everybody who hikes is whatever you take on the mountain, you take back with you. Also little papers, whatever. And if you see something in the cave lying, and if you see it, pick it up and take it out with you.
that helps us to keep
I
everything.
was thinking like it could be on the movies, but it was not like that, and it's like an eye-opener that if we go to Mars, it will be a really big endeavor, and we have to train it very good on Earth that we can go to Mars, and that's why we
Is
are
any
here.
training on the moon kind of similar?
no.
Because you see the guys jumping around on the moon and
Yeah,
it looks easy, but yeah.
It's a different kind of gravity, and it's also a different kind of soil. So it's
Yeah, I think the soil is quite sticky also on Mars.
Yes.
Because if you
yes.
see the rovers, it's
Yes.
sticking all over the place. Yeah.
It's also a problem to get all the dust
Yeah.
off it. Yeah.
Just talk about the spacesuit. There was like 2 months ago or something, or 2.5 months, there was the spacewalk of the 2 Russian astronauts from ISS, and it was broadcasted, the whole 6 hours were broadcasted live on the internet. I just want to have a look at after the first hour, and I kept on watching the whole 5 hours, and it was so interesting to see at a certain moment that the astronauts, they got tired, and their performance really went down. So ground station, they really were tough, telling them, like, you rest now. No, you rest now. They're completely motivated to continue, and they reordered them to stop. And it was really getting dangerous. They were like getting slower and slower, and we have the same factor here.
Yep. That's also why we have the safety here, and we also have a doctor, we call it BME, that's a biomedical engineer, who is sitting in the ops and always checking the vitals. That's why the ECG is so important, and we're happy to have it. Yeah, well, you know, you're a doctor, you can explain.
The autonomy of the battery.
It depends on how much fans we need. So we try to get it up to 6 hours. The battery, basically, and the electronics in the back runs much longer because it doesn't need so much power, but the fans are rather consuming. So.
Yeah, what is controlling the power of the fans? Is just a guy saying, well, I don't feel too good, or I feel too warm, I want to have it colder, so I'm working hard, so I'm starting to sweat, so I'm going to put another fan on? Or is it somebody in the control room who says, well, his heartbeat is up that much, so maybe you should turn on the fan?
Basically, there is always audio communication, which is a must-have if we are in the field. And if he feels hot, he either can use the voice recognition if it's
To turn it on. But it's him deciding it. It's not you deciding.
Yeah.
Yeah.
It's him deciding.
Again, a long time.
This one is for the inside the case. We cannot fill up the routers, therefore we have tables, LAN tables. Yeah. And then at some point there is a router, and the router communicates with the router, and the route goes via LAN. Yeah. This is too many stones and
Okay, we do another one?
That would indicate that there was some sort of fault between them, that it caused some relative motion. Could be looking for evidence of massive ground ice, and by massive ground ice I mean something that doesn't just fill the pores of the soil, but something that actually forms an ice lens or an ice wedge. That is something that could easily be...
Yeah, where would they put it down? Near the poles or?
Well, it's possible that we're finding increasing evidence of ice present in the subsurface at lower latitudes. Certainly it exists at temperate latitudes, and it may even exist within the equatorial region that EXOMARS is likely to set down in.
Okay.
We could be looking for evidence of contacts between lava flows. The main objective of the radar is to give us sort of the third dimension, to understand more than just what we can see with the cameras, which is the view that we've had in all previous missions to Mars. We've never had an ability to dig into the subsurface, at least to the extent that the drill is going to provide, or provide the perspective in terms of a remote sensing technique like ground-penetrating radar that's going to allow us to look in the subsurface without drilling.
And what kind of radar are you using?
It's a ground-penetrating radar that operates at a frequency of 500 megahertz up to 3 gigahertz.
It's not like nuclear or something.
I'm sorry.
It's not a nuclear isotope.
No,
Okay.
no. This radar, in terms of wavelength, will allow us to see layers as fine as a few centimeters, or rocks or objects of
You're also not going to have interference of the radiation that comes from space.
Not from space. Perhaps the greatest concern in the development of the instrument and spacecraft is making sure that other instruments on the spacecraft don't provide any electromagnetic interference. And so the spacecraft is being carefully constructed and the instrument carefully shielded to prevent against that kind of interference. But the maximum sounding depth that we expect on Mars is on the order of about 3 meters or thereabouts. The drilling depth, the maximum depth the drill can achieve, is on the order of 2 meters. So they're a good complement to one another. There should be a good safety margin there.
And how comparable is it to the rat device that's on Curiosity at the moment? It also has some kind of radar, but is it?
There's no ground penetrating radar on Curiosity.
What is the RID device? The rat, they call it.
Oh, that is a device that allows you to clean the surface off of rocks and maybe sample down to a depth of a centimeter or so.
So the RID, the RIT was on the old rovers, but Curiosity has a RID, and it's supposedly also to look in the subsurface, but I'm not sure actually if it's a radar.
I'm not. It's definitely not a radar. Wisdom will be the very first ground penetrating radar sent to Mars. There have been 2 other radars that have been in orbit around Mars, but they operate at much deeper, much longer frequencies and are designed to look much deeper into the subsurface. They really can't provide any information on what exists within the top 20 meters. The Charade radar is the shortest wavelength of those 2 radars, and really something on the order of 20 meters is about as small as it can resolve. Our radar will be able to resolve things from a few centimeters in size up to, again, maybe 3 meters in depth. In an icy environment like the one that we're going to be investigating today, we could easily get down to 10 meters or so. So ice is a much easier medium to sound through than rock and soil.
So an ice cave you would find it?
Yes. We should be able to detect the floor.
Sorry, this is Stephen Clifford. He is the PI of the...
Well, actually, I'm the deputy science team leader. The
sorry.
Her son is getting married today, so she couldn't be with us. Valerie Charletti at Latmos. And I'm here with a team of 6 other engineers and scientists who are also working on this investigation. We've got 2 instruments that will be operating at the same time. So one on the rover and then one on the little cart that we wheel around. So.
And also the Magma rover, we designed the rover to fit on the Wisdom radar. So there was quite beforehand some work so that everything works together. And yeah, it's also for the rover people exciting to have a science experiment on board. Yeah.
There's nothing top secret on the rover, right?
I don't think so, no? On the rover, there's nothing top secret.
No. What they're working with right now, what they just are getting ready to install on the rover are the 2 antennas. This is our cart, and these antennas are more clearly visible. The ones that are wrapped in the foam, that's an insulation material that helps cut down on electromagnetic interference, and so it makes the measurements more sensitive.
How long is it expected to last? Like lifetime duration?
The rover, I think originally the plan was for 90 days with solar power, with the hope that just like the Curiosity rovers, that not the Curiosity rover, the
Spirit and
that we would have a clean enough solar panel surface that we could do an extended mission. With the current agreement with the Russians, it's possible that an RTG, essentially a radioactive thermal generator radioisotope thermal generator can be used to power the spacecraft, and that can power it for years. So there are some significant benefits from the cooperation with the Russians.
You're gonna put a fan on the rover to blow the dust off?
We hope that, as was the case with the Mir rovers, that the winds will be sufficient.
Okay.
This is the PI of the Magnum rover, and we will also explain a little bit.
Yes.
And maybe you introduce yourself.
Yes, I'm Mateusz Józefowicz of ABM Space Education. We are the first Polish space startup. We are a young company, but actually the first Polish private company that really focuses on space technologies, and we want to make a living out of Mars technologies. We are kind of succeeding, but it's hard work convincing people that it is a good way to live. Anyway, we've been doing Mars rovers with the MarsScociety for several years, and this is the Magma White rover. It's one of our prototypes. We are basically building a mobile platform. There's going to be a universal platform for various scientific instruments. So that's why we are very happy to be able to cooperate both with Wisdom Georadar and both with the suit, because we are going to also do some tests with suit communication. So you may be able to control some functions of the rover from the suit. And this is going to be very interesting, I hope. Basically, we are now mounting the radar, and we've been preparing methods of positioning the rover without any GPS, because you don't get any GPS on Mars, so you have to look for other ways to get direct detailed positions of the rover. This is very important for the Georadar team, because they have to know the exact distances between each measuring point. So this is one part of the test today, and basically what we are doing. We are starting an education project on Kickstarter.com. We are the first space technology project from Poland on Kickstarter. It's called REMI. It's going to be basically a Mars simulator that is going to be available via the internet. It's both for individual users and for schools. We are gathering experience what to plant around one of small rovers which is going to be actually placed in our basement in Torun, in Poland. This is the birthplace of Copernicus, so the town has very good space traditions. We want to make the REMI available to international teams. So we plan joint operations when you've got one school from Poland which plays the role of engineering team, and then you've got a school from France or from other countries, from Austria, from the US, that do the science. They will have communication over chat and over video, and they will be able to control the rover completely through the browser. So basically, they have the teacher is gonna be their team lead, and the teacher will be in contact with us, so arrange all the windows of availability, and the students gonna be driving one of the small rovers. We've put new electronics on the rover, and this electronics we are testing right now is gonna be placed on REMI too. So this is both functional and equipment test.
Does the rover know where the suit is?
Pardon?
Does the rover have some detection that it can know where the suit is? Like, could you program it to follow the guy with the suit around, that it doesn't have to control anything?
Not this year.
Not yet.
But
Okay.
this year this is the first time we are working with AODA, and we will be happy if we at least get fluent communication of the system. And
But the guy in the suit still needs to tell the rover where to go.
Yeah, and for the next year, if everything goes fine, we will be able to prepare some more interaction between those two systems.
You can just say, follow me, or go ahead. And,
Yes.
And So that would actually be the rover that they take to Mars, or is that just for ExoMars you're doing that?
No, with ExoMars, we are only the platform for testing the georadar. So this rover has nothing to do in terms of technology with the rover that actually goes with ExoMars, because it's only a platform. But we also want to use the rover not only for space applications, but also for geophysical measurements.
I would also think it would be nice if it could carry the stones, like if you find some rocks, you put it on the rover and bring it to the spacecraft for flight back to Earth or something.
Yes, that's one of the functions. We have a robotic arm on the rover. It's disassembled right now, but it's standard equipment. It's a big arm made of light materials.
They're also making the rover strong enough that they can put a few on his back and carry them around, or is that not a function?
Yes, because it's got enough power and it is very light itself. Because it's made of it's not made of metal. It's made of plastics. So the parameters.
It's not that super strong carbon thing yet.
We are thinking of different materials, and for now we are testing the system and the structure, and the materials gonna be. We will have several versions of the body.
Oh, he is terrific, right?
If anybody has an urgent question to Daniel, he has the chance now.
If he's in there, he's not going to be able to.
Well, no, we don't know. Yes, he's still alive. Yes, it's still blinking.
It's your chance.
How many hours do you have to stay in the suit?
Today or today? I think until 4 o'clock p.m. 4 p.m. So 5 hours.
5 hours.
Yeah. So no food in between.
But I have water in the suit, and that's the most important thing.
How often have you been in the suit before?
That was 6-7 times before.
What's the hardest thing?
The hard thing, I think, it's the stretching, to bend my knees and my arms, and also the weight of the suit, because it's 45 kilograms. And I think
So,
it's
what is your background? You're not an army man or something?
No.
Because I know these guys train. These guys train in that, but
I'm a student. I did my bachelor degree in physics, and now I'm a master program in material science. And I do a lot of sports in my free time. Go running, drive a bike to the university, and also some fun sports activities. So.
okay. So I will probably fit for 10 minutes in that suit and be tired of it.
I'm fit for more than 6-7 hours.
Yeah.
So now it gets serious. You see, now we lift the hard upper torso from the supporting structure.
So how many crew members would you actually need to put that suit on? Like how many people at least do you need to send to Mars just to get the one guy
I hope
suited
on
up?
Mars we don't need so much people, but now we need 2 or 3 people.
Yeah.
It's a bit like in the Apollo times. I mean, the Apollo astronauts put the EVA suit on themselves, the 2 in the lunar module, landing module. Whereas when they trained years before on ground, you had always like 5-6 people around to help them.
Yeah.
That's a bit similar.
I think I read recently on the Apollo mission they left them on because there was so much work for them to put them on. They just left them on during the meantime.
Yeah, they part of them they left on.
By the way, this is what you see here behind. That's a very important detail here, and you'll see in a moment what it is for.
To sit on his
And it
knees
looks
on it?
very dramatic. You have to,
Kneeling down.
absolutely, yes.
For Cap Tom Checo from our
Middle Ages.
Yes.
He's a knight, yeah.
Might not be armor, but it's still a suit. Something.
Some Martian knight. Okay. Check.
From sport? Well, rover, the first place the rover
What you see here, there's also a procedure checklist here. That has supposed to be now it's the moment. That's a picture, huh?
Can somebody hug you on him?
So it is a good sport. Just like the humiliation wasn't enough yet.
Somebody should come with a lightsaber. Okay.
The advantage in space is that you're weightless.
Yeah.
Whereas here, you feel every gram of the space.
I think the actual video must be reviewed.
No, it's okay. Sometimes, you know,
It's stuck.
If something is stuck, it's stuck.
Yeah. Like putting on your backpack and you're stuck. And then that person just drops it and put it on again. What do I say?
Vertical shoulder strap is harder. It's possible to thread handles right up. While seated.
Do that face again.
Okay?
Yep. Right side? Yes. Okay. Little bug. Yeah. Yeah.
Smile.
We ask a lot of him, but smiling is not in the procedure. It should be.
It is. Okay. All the Mars Tweetup people, we we have to leave now. I hope you enjoyed it here.
Awesome!
Maybe we give a big applause to Daniel.
Daniel!
And see you later in the cave.
It looks quite stable, but this is all the movement, right? Ice is moving. It's slowly moving. It's water after all, and also this ice cave changes its appearance from day to day. We had some people who were here already on Thursday, and they said from between Thursday and today, Saturday, they see already differences in some of the ice formations, especially now in spring. Although the temperature here is pretty constant, but you get a lot of new meltwater coming in, which forms then the ice.
But what will happen? Will there be layers or will it move?
There are layers of ice. So the oldest ice in here is about 400 to 500 years old. Not older than that, because still it does change. And also partially it melts with warm wind coming in summer. So the oldest layers are about 500 years.
But it's not like if you make a marker there that tomorrow it's going to be 1 meter further.
No,
there's going to be a no layer on top of it.
If you make a marker here and you come next season again, it's gone.
Yeah, because a new layer is on top. It's not moving underneath a bridge.
Yes, exactly.
Yeah.
Now this is one of the domes where we will conduct the experiments. Some of the experiments, especially the cliff spot. I don't know if the cliff spot is up there. Yeah. So this will go down, for example, this slope here, and the ice is obviously pretty slippery. So you have to pay a lot of attention because you don't want to slip down yourself. All this here, and then it goes down here more than 40 meters behind these ice formations. What we do now is we go in deeper into the cave, and we go into a dome that has no ice. Well, we'll do mostly the experiments where the Aouda spacesuit is involved, because you can imagine we don't want to have it have the suit tested walk too much on the ice. You can do it. He has spikes on the shoes, which was very funny up there right now, where there was a wooden platform, and he was standing there for the press to take some pictures. And when he wanted to move, he couldn't, because the spikes were bitten in the wood, so he was stuck. We had to take him out again.
How did he get through the lower area there?
It's very difficult. Basically, you will see the suit. He's still waiting for us. You'll see the suit. When he walks, he goes like this in the lower areas.
Oh, he can do
It needs to be like this, 90 degrees, and somebody in front takes him on the helmet and leads him, and two people walk behind him. It looks quite funny how they walk behind him. One is walking with first aid and rescue kit, and the other one with a fire extinguisher. Now, why do you need a fire extinguisher in a cave, in an ice cave especially? You do need it because he has electronic on board and batteries. And it can happen, and we're not sure under which conditions it can happen, that these batteries explode or catch fire, and then you want to have a fire extinguisher right next to it. So you see always the people walking behind with the... Yeah. Okay, do you have any specific questions to the cave system or the experiments we do here? So here's the cliff spot especially. We do some sterile sampling at the rocks up here and partially also at the ice. You see partially, if you look carefully, the wind direction. Sometimes even on the ice. I don't see it here, but there are so-called ice needles. Over there you see them, yes. Wonderful. And here, yes, on that side of the large structure. Where you run the wind direction, the ice growing in the other direction. So with the wind, basically. That's very fascinating.
The person inside.
Okay, then I would say we continue down to the large...
Exhaust. Oh yeah, he did have it on.
GQ.
Contamination experiments, he has to take some soil sampling and try to do it as sterile as possible. There are some interactions planned with the rover. The voice recognition software inside, which is tested. The spacesuit is from software and hardware. It's completely new than to the spacesuit we had last year at Rio Tinto. So the spacesuit itself is also an experiment. There's a medical experiment ongoing with the ECG device. These kind of things. There's a flight plan which is quite full, which experiments they have to do. It's full, and some of the other teams want to interact with the space.
Basic things, so for example, if you look at this rover, is that it has the capability to drive 360 degrees with every wheel from the top side and of course from the side perspective, which means it can drive in any direction it wants to. There's no front or back side of this rover. There's even no wheel left or right. It's a little bit complicated when driving, but it has actually some advantages to it. Also, if you look at all the Mars rovers that we currently have, and also of the previous lunar rovers, then you will notice that it just only got 4 wheels, which is a little bit awkward if you compare it to all the other ones. So once we proposed our design of a 4-wheeled rover, everybody said, "Oh my God, why are you doing this? You need to have 6 or 8 wheels." And we said, "Why?" Because, well, what's the reason behind? Yeah, it's more stable and you have a lot of advantages. And we said to them, okay, we can show you that we have much more advantages with 4 wheels, which is something we really did. So this rover that you can see below, and that you can maybe even drive yourself if you like, is a vector-based control. So you can actually just point a direction where you want it to go, and it can go there how that lies. It's pretty complicated to explain.
You're pointing there?
No, it's pointing. Currently we're having so-called tablets, just normal Android remotes that you can use to drive around the rover. It's something we've developed for kids at exhibitions. It's not meant for the production environment. For real production purposes, we are using a 3D navigator. So you have these 6 dimensions and movements, and you can turn it in this.
Other one from 3D connections?
Yeah, of course. Okay. I think it's the only viable ones that you can use for such purpose.
Right.
Yeah, of course. And so feel free to ask questions anytime, because I don't have any slides, so it's always good to have a dialogue going on. I got some cool videos to show. We'll do this after we through with the general questions and Q&A. So in general, we're not just building moon rovers, because our goal is actually to get up there to the moon, and hopefully way before 2050. So that is why we're also building lander prototypes. We already showed one lander prototype, which is the Azure version of this lander model. And yeah, we're going to have to provide some more along the next 2 years. Our goal is actually to launch early in 2014 and have it as the very first private commercial space mission. Commercial always sounds a little bit bad, but I really want to do it in a very good way, because I really want to provide something again for everybody in the scientific community. So, for example, bringing technology that you already know. That's why I'm coming back to this guy. There's technology that we have in the industry that is way far more advanced than we have currently in aerospace. If you take about 40 years back, then you can see that it was completely different. We had technology from aerospace coming into the industry. Right now, what we want to do is we want to bring great solutions that we have in our everyday life. For example, the processing power of a smartphone to a lunar rover. Because if you look at the processing power of, for example, the latest Mars rover, then it really is not that much. We're talking about 100 megahertz or more, which is not that much if you want to, for example, do HD in real time. So all the cool stuff. And it really is a constraint for all the scientific components. So you want to do some scientific analysis of data in place, or you want to do, for example, real-time 3D autonomy, then you really can't do this with 100 megahertz. The reason why the people are doing this is not to save money. That's not their problem. Their problem is actually they have to build components in a way that they are radiation hardened and so can sustain the environment. The lunar surface is actually much more complicated than the Martian environment. Sending a rover to the moon is much harder than sending it to Mars. Why? I can give you some reasons for it. In general, if you take your average Mars rover and would bring it to the moon, what would happen with it? The average Mars rover would maybe drive like 10 meters and then will stand there for, I don't know, eternity. The reason for this is regolith. The regolith is the lunar soil, which is very, very tiny fragments. It's very sharp. So, and it gets into every part of your system. It gets into the bearings. It crawls their way into the system. So, and there's really no way to avoid this. If you think back, the Apollo astronauts had a problem when they came back into their capsule. They were all covered with lunar regolith. How is this possible in an airtight suit, which is pressurized? So you can think how small these particles are. So they're really getting into the bearings, and if they're in the bearings, then your rover does not move anywhere, anytime. At least not without help from the ESA or something like this. So that is one part. The other thing is that, for example, the moon has absolutely no atmosphere. So what does this mean? Right now, over here, if you compare the situation, for example, with this smartphone over here on Earth, with this smartphone on Earth atmosphere, the difference is the level of radiation that is applied to the electronics. We have pretty advanced technology, which is cool. The problem is, this technology has a lot of intelligence and a very small chip, which is something that we didn't have back in the 60s. So, if a radiation particle hits this very small chip, which is very likely because it's very dense in this area, then this chip is definitely fried. And you have 500 times the radiation level on the moon than you have on Earth, because there's no shielding to protect you. So what you need to do is you need all your fancy electronics, all your high-speed computing power, you need to protect it from radiation, which is not that easy. And one thing that we're doing is, for example, utilizing FPGA technology, which we're utilizing parts of this technology which has some components which can also heal itself from radiation infections. So if we have, for example, one area of this chip, of this FPGA, which is damaged by a radiation particle, then it can recover from this damage. It does something like, it's a little bit like rebooting and then readjusting. It's like you can compare it with a hard disk. If you have a hard disk in a computer, then you have always one unreserved space that you can't use, which is used for error correction. Once an error, a bit error occurs in a hard disk, then this bit section is reallocated to this section. That's the same part of technology that's being used for FPGAs. This is just one thing. The same thing does apply, for example, to the sensors that we're using. We're partnering with a company who's supplying sensors to nuclear power plants. Normally they're using their sensor technology to monitor the inside of nuclear power plants, which is actually pretty good. So these sensors can actually withstand a lot of radiation. So we're just modifying a little bit to make them space suitable, which is not that easy because space also provides challenges on their own. If you look at the way the sun is coming down on your electronics, the sensor itself. So there actually is a lot of challenges associated with it. And we are trying to find the best solution, and the best solution with industry technology that is already there. We are not trying to invent something new. Of course, you're always inventing something new when you're building technology. This is always a new invention in itself. But the goal is actually to use the best, and in this case, cheapest approach to find a good solution for a low price. So to summarize, making the space more accessible. I think this is really something that is important for everyone. General questions, because otherwise I can continue talking. I'd say could be problematic in regards of food or something like this.
Really like the T-shirt.
The T-shirts are awesome. If you want one, just get in touch with me. We have some with us, but we haven't taken it up.
I'll take you up on that.
Yeah, it's also, of course, one thing that is also very important to us is public outreach work. Because one big challenge that the entire industry has is that we absolutely have no engineers left. I can definitely tell you, finding good people is actually a really hard challenge. And I can tell you that all companies in the entire industry are always coming to us and say, yep, if you have somebody for us, just give it to us. We're giving you money, everything. Just give us this guy because we absolutely need somebody who knows how to do this.
Yeah, maybe there could be a lunar Tweetup or something for organized by the ocean scientists in one part of the
Definitely. I definitely think we will have a Tweetup, I don't know, when we launch. So it's something to express this with these hell yeah, it's rocket science. This is our motto. And it's not just this model, it's also a social network site that, for example, have on Facebook, where people can see what we're doing. You can see all these videos of how we're building stuff and how we're approaching things and testing and so on. So, for example, we'll see a video how we're testing this rover outside today, how we got here and that's. So we want to make space interesting again for the general public, which is a tough challenge, but I think we're actually on a good way. Because one thing I noticed, when I, for example, go out there, maybe just in a public place on the street, and talk to 10 people about this project and tell them, for example, about Helia's rocket science and what we're doing, then we actually have 12 fans later on. Because why? These 10 people are absolutely amazed and tell at least 2 others, which is something that's pretty cool. So it's important. It's important to bring space back into the general public. Because it helps everybody. Because it also helps to raise the awareness and get, for example, politicians behind space missions again. Right now, I think I can't say a good number, but I would say that the vast number of space missions is announced and cancelled, which is pretty normal. I don't know. They announce it once because they want to get elected, and they cancel it pretty soon later on because they say bunch of constraints. It's always the same. It happens a lot of times in Germany, and I think it happens a lot of times all over the world. It just recently happened with NASA, which also affected a lot of European missions as well.
But at least in Germany, you're lucky you have a human spaceflight program. In Austria, we don't have it.
Yeah, I know. That is also a good concern.
Are you people going to be at the ISS symposium in Berlin? Are you going to be at the ISS symposium next week in Berlin?
No.
I think so. This whole symposium there, my impression is a lot of politics, mostly actually politics, and get leaders into do the funding.
Yeah, the point is we actually don't want to deal with politics at all. That is a very strict rule that we have. We don't do any kind of politics. Good rule. So we totally stay out of this. What we want to do is, as I said, technical solutions, really do technical work and do this thing. So I think convincing politics is just by action. That's the best way to prove it. And if we're successful with this mission, I think then we prove a whole lot of things. So that is one of the reasons why I said we're working with so much industrial partners. Working with industrial partners always sounds a little bit, I don't know, for some people it sounds a little bit bad, I don't know, maybe, but in our case it really is that we're providing benefits for both sides. So it's always a symbiosis? I don't know, symbiosis? Symbiosis, thanks. So that we're always giving them pieces of technology and they're providing us with pieces of technology. It's a very good way. So we can jointly develop new technology, which is very important.
So what do you think, which is the biggest competitor in the Google X Prize for you?
The strongest competitor? I think the strongest competitor is the US government. The reason why I'm saying this is because we have 26 teams. If we lock it down to the teams that are really actual competitors, then I would say we have about 5 to 6. And there's really a strong force in the US to make sure that the US will be the first on the moon after 42 years. You can see it in a lot of things. There are a lot of funding programs. So in the US, actually, teams can go to NASA and say, we want to build a moon rover and give us like 10 million for this, and they actually can get it. You also got it. I think NASA already gave away up to 40 million about it. So it's quite good to go to government and say, hey, we need money for a new lunar mission. It's not something bad for us in this way, but it really shows that they want to do this, which is a good thing. I think it's okay. It's okay that they really want to get back to the moon with this approach, but it's not a really balanced competition.
Yes.
I'm still wondering how the suspension works on that rover you got there
I
now?
can tell you more about this if you look at the wheel prototype. Not real. This one is real as well, but at the wheel one below, because we have a lot of things with suspension. There's an active suspension system in the rover, which of course this one doesn't have.
Oh, okay. Yeah. So it's just
it's a static model. The reason behind this and this other one is just a simple money. For example, when you're normally developing such mission, then you're building, I don't know, just build a prototype and everybody tests with this. So if you take the price tag of this prototype, it costs way into the 100,000 euros.
Yeah, but if you look like the Mars rovers, they are climbing over rocks and you have those 4 wheels at a fixed location. Okay. Yeah.
And this one is a specific prototype. It got the same software architecture, which wasn't that easy. So you can actually port all the software from this system to the production system, and it got the same way of moving. I think it's called kinematics. I don't know if it's the right word. The way the wheels and this entire system moves and behaves. So actually, the people, our software developers, we have more than 20 software developers, have one of these on their desk and can program everything with the same operating system. We're using the QNX real-time operating system. Which QNX real-time, the RTOS. It's not Linux because a lot of people suspect that we're using this, but it's very important to have a real-time OS. The goal is it's actually the very same operating system, and people can develop the software on this platform, which costs about 300 euro for us. And one production rover current cost would be 150,000 euros. So if I have 20 developers and everybody wants to play with the rover, then it's definitely not a good thing to buy like 10 of these other ones.
Making a wheel. Can you do that on Mars?
If we could do that, then Spirit will still be driving, I guess, because it looks exactly what it needed.
Oh ja, klar. Und mein Vater kommt eigentlich oben von...
Is it possible to spin just one wheel, like they're doing on Mars, to kind of grind into the ground?
It would be possible, but not from this current version of the...
Okay.
Ah gut, also...
Aber da konnte ich nichts machen, da war ich noch so.
Okay, mein Vater kommt auf Löschen da.
Oops. You need more grip.
So,
somebody sit on it.
The Asimov is here, we won't see it in the cave, unfortunately.
Yeah.
But at least we see it here. Sebastian and Daniel. Sebastian is a flight plan. Daniel is one of the suit testers. He will be in the suit tomorrow. Sebastian, do you have time to say some few words?
Yeah. I'm doing the flight plan, meaning we schedule experiments, see if the experiments are delayed or earlier in time, so then we reschedule it to make sure that the guys are on site at the right time, so that the experiments can start without that we have a major loss of time.
And Daniel, as your suit tester tomorrow, what's your job today?
Today, I have more or less it's my free time. I was in the suit yesterday. We did a short donning and doffing just to test the whole system. It went very well, and yeah, it was a successful first test. And I'm looking forward to tomorrow.
Yeah, we just saw the other suit tester, who is also, his name is also Daniel, in the King Alpha Dome. Yeah, they had quite a long walk down there. So
we select our suit testers according to first name, so if it's just Daniel, it's much easier to communicate with.
Okay, and the person with the tie, this is the most important person in the room. This is the flight director. It's Norbert. I think he's missing, so do you want to say some words to the Twitter people?
Hi, welcome. Welcome to the operation session. Do not cross this line! Everything running fine so far. I don't see any sweat curls, so I'm in good shape.
Yeah, what's your job here?
What's my job? Safety science simulation, the 3S principle. These are the guys who make sure that safety is absolutely obeyed. So we check the medical data and everything else, and in case we see a really issue coming up, we first check it out, and in the worst case we just pull the plug. It's you guys so far.
So he falls down?
Yeah, he breaks down. Right? So we are really here to protect the astronaut and the crew. And of course to make a compromise as much as possible with safety science simulation. So the science is there, do good simulation, but really the safety is obeyed.
Okay.
Important.
Thank you. Another important person over there is the Capcom. Capcom, you know, everybody knows from the movies. Like this is the person who actually talked to the suit tester. This is Reinhard today. You want to say some words?
Well, basically you just said it. So I talked directly with the suit tester, and I'm one of the few people who should be talking to the suit tester for his comfort as well, because if you have too many voices in your head, it won't work out normally. So basically the decision is made here between the flight planners and the flight director. And then they tell me, well, so they tell the suit tester, is it possible to pick up the rock or to go there and this kind of stuff. So this goes through me to the suit tester so that he has a very comfortable voice to listen to and he's safe and relaxed.
And the last console, this is UDA TTC. This is, means tracking, telemetry, and control. Egon, who is also our doctor or our PME today, is on this console. You want to say some words, Egon, to the people?
I do some medical checks
and you know, this is the guy who made the Egon device you saw earlier this morning, the ECG. This is Egon from the Egon device.
This is Egon from the Egon.
Yeah.
Egon gives us all his device.
Yeah. Over there, this is a table where also our experimentators have some place like for doing science and so on. Yeah.